My name is Ignatius Bunk, and today we'll talk about an area of chemistry known as stoichiometry, which is the study of mass relationships. In a chemical reaction, stoichiometry requires a balanced equation, and we'll explore the basic topic of balanced equations with the simulation made by the University of Colorado. We'll begin with the introduction. Consider the formation of ammonia by reacting nitrogen gas with hydrogen gas. Now we will begin by balancing everything other than hydrogen and oxygen first. So we'll balance the nitrogen first. Now nitrogen is balanced, but if you notice we have 6 moles of hydrogen on the product side and none on the reactant side. So we just need to add 6 to it. And there you go. We have a balanced equation. So we consider the separation of water to hydrogen gas and oxygen gas. And we'll utilize this nifty visualization tool they give us, and we have a pair of balances. And we have a balance for hydrogen and a balance for oxygen. Now, we don't have anything other than hydrogen and oxygen, so we'll just go ahead and add a water, and we'll notice that we have the balance of hydrogen has 2 moles of hydrogen on the reactant side and none on the product side. Same thing with oxygen. So the next thing I'll do is go ahead and balance oxygen. Alright, so if you notice here, I tried balancing oxygen, and it added 2 to the product side, and we have to rebalance on the reactant side. Alright, now we have oxygen balanced. But if you notice here, hydrogen, we have 4 moles of hydrogen on the reactant side, none on the product side. So we'll have to add a total number of 4, and there you go. We have a balanced equation. Next, we'll consider the combustion of methane to carbon dioxide and water. And we'll use a different visualization tool. We have it's like a little bar graph. And we have carbon, hydrogen, and oxygen, and we have it's the same setup. Lets us know that it's not equal. And when it's equal, now we'll balance anything other than oxygen and hydrogen first. So we'll balance the carbons. So now we have carbons the moles of carbons are balanced, but everything else is not. So if you notice here, we have 2 moles of oxygen on this side, none on the reactant side. We'll go ahead and balance that. Now, if you notice, we have 4 moles of hydrogen on the reactant side, none on the product side. Now we'll go ahead and balance that. So now the hydrogens are now balanced, but now if you notice what happened, we had added 2 moles of oxygen, and now it's unbalanced. So we need to rebalance with oxygen. And there you go. We have a balanced equation. Now, if you want, we can refresh the page, and you can do this over, or you can play one of these nifty games they give us. And they have level 1, 2, and 3. Level 1 being the easiest, 2 and 3 being harder. We'll try level 1. Same thing. Balance everything else but oxygen and hydrogen first. So nitrogen gets balanced first. Now if you notice, we have 6 moles of hydrogen on the reactant side and none on the product side. So just 2, 4, and 6. And there you go. And it lets us know that it was correct. Moving on. Everything else other than hydrogen and oxygen first, so balance the carbons. Now we need to balance oxygen next. Now next one, same thing. Balance everything other than hydrogen and oxygen first, which we don't have. Now balance the sulfurs. Balance everything other than hydrogen and oxygen first, so balance the carbons. Our carbon atoms are balanced. Now we have 6 moles of hydrogen on the product side and only 2 on the reactant side. So go ahead and balance that next. Now we have 6 and 6. Everything other than oxygen and hydrogen first, so nitrogen gets balanced. And oxygen's next. Oh, okay, you have to rebalance, like I said once before. rebalance. That was right. And it lets us know that we've successfully finished. Okay, and if you reset it, or you can continue, and this concludes our simulation guide, and I hope you've enjoyed it. I know I have, and it's a great simulation to use to learn how to balance chemical equations. Thank you.